Okay, hey guys, my name is Jacob, and this is Calculus A lesson on limits. So let's get started. Okay, so these are the videos I made on limits only. So I made video on basic limits, which is if we have a limit of uh, a function x approaching a constant or approaching plus minus infinity. And the second one is limits involving absolute values and limits involving trigonometric functions. Then continuity. So this is basically exam preparation. It's not going into detail. So I'm assuming by this point you have been through your studies. You have studied, because here it's exam questions. It's what they said. So from the exams I've seen from 2014 until 2020, the exam questions are the same. They're not setting the same thing. I'm saying it's the same style. So question one is your limits, your squeeze theorem, and other things for 25 marks. So question one is that first unit uh, on limits and derivatives. Okay, so yeah, let's get started. So the red one, it means this is the video. The video is about that red chapter. So if you check other videos on limits, you will see with the red color that this video is about basic limits or continuity. So this one is about basic limits. So I'll start with if your x is approaching a constant. So the first thing I would like you to always do if you have a question like this for a limit, first thing every time, substitute the number they give you on your limit there and check if you get an answer. If you get undefined, then now you have to take another approach. Like here, if we check our first question there, if they ask you to determine the limit of this, so you can see if I substitute my 2, I will have an answer there, which is 4/3, and it's done. Then the second question, we can see the second question already in the bottom. If I substitute 2, I have 0, and if we divide by 0, we have undefined, right? So which means we should try simplify it or find another way to do it. So we can see at the top we have difference of 2 squares, which is x squared minus 2 squared, which is that 4. So if we do difference of 2 squares, so don't forget you write this limit until you substitute. So if I do difference of 2 squares at the top, this is what I will have. Then we can see x minus 2, it cancels the term at the denominator, then we are left with only x plus 2. Now you can substitute. If I substitute my 2, I have 4. Now the next one is this one, where you have a square root. With this one, this question is always there in all the questions, the question papers I've went through. This one, between 1 and 2, they can give you only 1. But 1, it's usually rare because it's straightforward, but sometimes it's there. But number 3 is always there, so you should know how to work out with this one. So usually people say you multiply by the conjugate, but the easy way, I believe, for me is to change. Okay, let's start here. Okay, but first of all, remember you have to substitute. If I substitute, we can see 1 minus that is that. So we will have 0/0, right? So now we must try simplify that. So this is what we are going to do. So I will have, okay, at the top, if I decide, this is the easy way for me. If I decide to take out negative, I'll be left with square root of x minus 1 at the top. I hope we still remember that x is the same as square root of x squared. So which means if I have square root of x minus 1, this is the same as okay, not this one. Yeah, so yeah, just remember that if x is the same as square root of x all squared, right? So which means at the bottom, if I have x and 1, I can make it difference of 2 squares. If you can master this this method, you will see these questions, you won't have any problems with them. But you will see when we do other questions from the question papers. So that's what I'm going to do. I'm going to change the bottom part to be difference of 2 squares instead of multiplying by the conjugate. So this is what I will have at the bottom. I'm making this difference of 2 squares. Then what happens? This cancels this. Then now I'm left with limit x approaches 1. Then I'm left with what? At the top I'm left with negative. At the bottom I'm left with square root of 1 plus 1 there. Now if I substitute, you can see I'm left with 1 over 2 because I'm going to substitute 1 for x there. So it will be square root of 1 plus 1, which is 1 over 2. So let's do a few questions on this from the exam, from the final exam, and see if we can apply what we learned so far. I want to keep this video short, yeah, to not waste time. Okay, here's the first question. Okay, this question I clearly made a mistake. This is a square root of t, not 2. This is square root of t. So this is more or less the same as the one we just did now. So which means if you check it, I'm going to change this t to be, remember we know that t is square root of t squared. So I'm going to make the bottom one difference of 2 squares. So this is what I'll have limit as t approaches 4, I'll have 1 minus square root of t. At the bottom I'm making that difference of 2 squares. There, what happens, this will cancel this. Then now I'm left with limit t approaches 4, 1 over 1 plus square root of t. If I substitute, I have 1 over 1 plus square root of 4, which is 1 over 3, just like that. So sometimes they can start with square root, but remember, always make it difference of 2 squares. It's easier instead of multiplying by the conjugate and everything. Let's make it difference of 2 squares. Okay, so this is from June 2020 question paper. Now the next question, it's also from June 2020. So this one is determine the limit of that. So first of all, we substitute. So if you substitute, you can see at the top you have 0. If you substitute at the bottom, you also have 0 because you'll have 4 plus 2 minus 6. So which means we have to try another way. So another way is to simplify. So if we simplify the bottom, since we have a polynomial, we know the factors of 6 to give us 1 is 3 and 2, which is negative 3 plus 2. So do you see your 2 and 2 cancels? So now I'm left with limit x approaches negative 2, 1 over x minus 3. Now if I substitute, I have minus 2 minus 3. So my answer is negative 1 over 5. Just like that, and it's done. Okay, so remember, this is a video. You can just, if you don't understand, you can just reverse and check it again. So now I'm going to your infinity, your positive and negative infinity. So with this one, we should take note of the following two expressions there. So if you have 1 over infinity, your answer is 0, because this is infinity, means your number keeps on increasing. So you can check it. If you say 1 over 2, you get 0.5. If you say 1 over 20, you get 0.05. If you increase it to 200, you see your number is getting closer to 0. So another thing, if a is any number over infinite exponent any number, your answer is 0. These two are very important because this is how you're going to use them. If I have, for example, let's say I have a limit of x approaches infinity, then I have what I have, let's say x squared plus 2x minus 2, let's say over x cubed plus 3x or 2x minus 4. So what you're going to do every time, you will remove the number, the term with highest power or highest exponent as your common. So at the numerator, you can see the highest exponent is 2. So I'll remove x exponent 2. Then we know I'll be left with 1. Here I'll be left with 2 over x. Here I'll be left with 2 over x squared. At the bottom, you do the same thing. You remove x cubed. Then here I'll be left with 1. Here I'll be left with 2 over x squared. Here I'll be left with 4 over x cubed. Then now you can substitute. So now if I substitute, check something. If I substitute, but you will see when this is the question I made up in my head, but you will see when we do this thing actually. So we can see this one, this x squared will cancel 1x, so I'll be left with 1 over x. So at the top I have only this, then here I have this also. So what's gonna happen if I substitute infinity? Do you see this will be 0 because this will be a number over infinity. This will be 0, this will be 0, this will be 0. So at the top I'll be left with 1. At the bottom I'll be left with what? With this 1 in brackets over the x. X is infinity, and we know 1 over infinity is also 0, just like that. But let's do some questions and see if we do get it. But these two are very important. Okay, here's the first question. We can see at the top we have the highest power of x. This is x approaching negative infinite. That shouldn't confuse you, never mind it. So at the top I have a power of 3, so which means I'm going to remove x to the power 3. Then I'll be left with 1 plus 2 over x minus 1 over x squared, because I'm dividing by that everywhere, plus 10 over x cubed. At the bottom, my highest power is x squared. So here I'll be left with 2 minus 1 over x plus 3 over x squared. So now we have to substitute. Okay, before we substitute, we cancel our x's together so that our working can be easier. So I'll be left with x here, then everything in the bracket. At the bottom I'm left with only this bracket because your x squared was cancelled by the term in the numerator there. Then now if I substitute, do you see I have infinity here, which is my x. Then I have 1 plus 2 over infinity minus 1 over infinity squared plus 10 over infinity cube. You don't have to put the exponents, they mean the same thing. Then at the bottom I have 1 over infinity plus 3 over infinity squared. So do you see what happens? At the top I'll be left with infinity multiplied by 1, because this will be 0, this will be, if anything divided by infinity will be 0. At the bottom I'll be left with what? With 2 minus 0 and 0 there. So my answer is what? It's only infinity, because infinity over 2, it's still infinity. Infinity is a big number. So my answer is infinity indeed. I hope this is clear. Okay, let's see another one. Okay, this is from November 2019. They say determine this limit, we have limit t approaches negative infinity, t squared minus at minus bt plus ab over b squared plus 2abt minus a squared t squared, and a and b are real numbers but they are unknown. So we do the same process again, remove the term with highest power, so which at the top it will be t squared. Then I'll be left with 1 minus a over t. Remember, if I remove t squared, I'm dividing everything by t squared. Then here it's b over t. Here it's plus ab over t squared. At the bottom, what's the highest power? It's also t squared. Then here I'll be left with b over t squared plus 2ab over t minus a squared. So what happens? My t squared at the numerator cancels the one at the denominator, so I'm left with this I'm left with only this and this. So now let's substitute. This time I'm not showing it, I'm just substituting. What do we know? We know everywhere you are dividing by t, I'll have 0 because I'll substitute infinity. 0, 0, 0. So at the top I'm left with 1. At the bottom this is 0, 0. So at the bottom I'm left with minus a squared. So my answer is minus 1 over a squared. That's your answer there. Okay, let's do some quick revision. Okay, now we are doing quick revision and see if we understand. Remember, how are we going to solve this first one? If you have square root, but if you notice first, we can change the square root of 4 to 2. So this is square root of x minus 2. You see? So now we can clearly see we have difference of 2 squares. We have difference of 2 squares at the top. If we change x at the top to be something like this, so that it's clear, this is square root of x squared, and this your 4 is 2 squared. So now I hope you can clearly see this is difference of 2 squares. So which means if I simplify this, I'll have square root of x minus 2 square root of x plus 2. At the bottom I'll have square root of x minus 2. So now I'll be left with only square root of x plus 2. So if I substitute my 4, I'll have square root of 4 plus 2, which is 4. Just like that. You see what I did again? Difference of 2 squares. So the bottom one, you check. If I substitute 3, will I get undefined or anything? Remember, every time I substitute, even the first one I substituted 4, at the top I got 0, at the bottom I got 0, which is undefined. That's why we had to find another way. This one, if I substitute, I won't get undefined. I can see at the top I have this, at the bottom I have 3 cubed plus 2, 3 squared minus 3. So I'm going to substitute this. I'm getting 14 at the top. At the bottom I'm getting 42. So 14 over 42, it's 1 over 3. So you have to check first before you try to simplify. Okay, now lastly it's this one. This is infinity. Remember, infinity, every time you deal with infinity, the first thing you should think of is removing the highest power. So if you can check, we have two terms here. We have term of this first bracket and the second bracket, and we know according to our theorems we can write this, we can separate this to be this is plus 90. We can separate this to be exactly like this. Perfect. So now we can simplify. If I simplify, okay, it doesn't look like I'll have space. Let me write here. If I simplify my first term there, my t squared is the highest exponent, so I'll be left with 6 plus 9 over t. At the bottom, I have 3t squared. So we know t squared and t squared will cancel. And I'm going to the next term. I have t squared, then I'll be left with 10 over t squared minus 1. Then I have t squared at the bottom, I'll be left with 1 minus 7 over t squared. So now let's substitute. If I substitute, what happens? Okay, before I substitute, we know t squared will cancel t squared. Here t squared will cancel t squared. So now substitute. Do you see? The first one I'll be left with 6. Because 9 over t will be 0. So I'll be left with 6 over 3. The second one, I'll be left with minus 1 over positive 1 because 10 over t squared will be 0, 7 over t squared will be 0. So that's your answer there, minus negative 2. Okay, yeah guys, that's all for this lesson. I'll see you when we do some other topic. Alright, thank you. So if you have any questions, you can email me or leave a comment. Bye until next time.